Hello, everyone. My name is David, and with me is Daniil. Thank you very much for having us today. It's an honor somehow to be here, and the organizers wanted us to talk about the journey of CyanView, going from... Switch. No. Sorry, start again. Yeah, so the journey of CyanView, a company that uses Elixir from day one as a startup. And we went from an idea to delivering hardware control panels to control cameras that's been used on the broadcast industry on very good productions like the Super Bowl, the Olympics, and now concerts like Coachella. So what do we do exactly? We control cameras for TV, and if you look at the Super Bowl, for example, it's between 20 to 40 cameras or signals. And you see the pylon there, the small orange thing there, and there's three mini cameras in a pylon. There are four on the field, sometimes 8, that's already 12 to 24 cameras. So it's quickly a large number of cameras. And they could use drones, they could use some other mini cams as POV. And then they had this thing in 2020, which is somehow a picture camera. It's a mirrorless camera that they started to use to have cinematic shots and immersive, so they were very close to the action. And they used that on the Super Bowl in 2020. They loved it, and they called that Megalodon. And they asked us, well, can you control this camera? And so we looked at it with Sony. They gave us like an early versions of an API they were looking at. And we got control within 2 weeks, so they could use that on the next NFL season. And somehow, within the next year, it took up all over the US. Most of the NFL productions and some other sports were starting to use this kind of cinematic effects. And it took something like 2 more years before Europe actually did the same. And then they started to have these cameras on all the events. And at Paris 2024 Olympics, they had that on a lot of venues to take shots of the crowd from the sport themselves. And so whenever you see those two blue box there attached to the cameras, you know there's some Elixir code running in the field. So we put together a small demo here to show you exactly this. So we have our RCP, which is the remote control panel that we have here. So remote control panel for cameras. Whenever I change something on the RCP, the data is sent over wireless in this case, to the Rio, which is another blue box that we do, and that one controls the camera. The video goes on the side, so the video is sent through another type of wireless link, and that goes to a third box that we do, which is a video processor. That's a 4-channel version, and that usually adds a bit more controls that we need for TV, for broadcast, and some of those cameras offer. And so the RCP controls both the camera and the video processor. So if I switch to the view that we have here, we have, for example, on the RCP currently, you see the screen there. That's a first minicam, that's the camera which is there, which is actually looking at you. And so I can change the brightness, I can change the black level, which somehow black level is what brings contrast to TV. We don't have brightness and contrast, we have gain and black level. That's actually some of the settings that are different from like consumer cameras and real TV. The settings are very different. And if I go to the second camera, which I didn't start, so that's going to be my Megalodon shooting the curve chart there. You see that it's the same. I can actually change so I have access to the black level, even though the camera doesn't do it. That's done in the color corrector, but if I do the iris exposure, then that's actually going to the camera. And to give you an idea of the options that we have, if I go to the paint menu there, you might see this more on this screen. I go to the root, I have like 20 menus there, and each menu will have many settings that I can change. If I just go to some of the detail, and I mean, there are many pages of settings that we can have. So it's actually getting very complex. And to show you an example of what we can do with these cameras, if I have all my production on, let's say, a football game, when you switch between cameras, the green of the grass will look the same. So you don't see really the difference in the picture. But when you put a camera like this, the grain of the grass is not going to be the same. The sensors are different, the processing is different. So you need tools like this one here. If I go back to the multi-view, I have a multi-matrix. I can enable a gate effect, which is going to isolate a vector, and I will select the grain of the grass. So where is the green? It's probably there. And so you see in the circle, that's what shows the curves. I can remove the gate effect. And now I can change the saturation. So you see on that circle that I changed just the green color. So I can make it more cyan, I can make it more yellow, and that's only the green patch that changes. So that's a tool that you can use to take any kind of specialty camera, put it in the field, and still try to use that to match the main cameras and being able to use different angles, different specialty cameras in a real broadcast solution. So how does it work?
So yeah, just quickly explain. Each box is running custom Yocto build, and each Yocto build essentially has the full beam running on it. So we don't have any light versions like Atom VM or things like that. So it's actually the full-scale machine, and each device has its own MQTT version. So it has its own instance, and we don't have the shared MQTT. So each device has its own. And in that demo scenario, our RCP sends the signals directly to some of the cameras via the IP through the TCP. And we have currently the setup with the Rio, where the RCP sends the TCP signal to the Rio, and then the Rio box sends it to the camera. So in that case, that's how the demo works, and we will explain a bit later why those architectural decisions were done from the Elixir and the technical perspective.
So back to the beginning, we started the company in 2016. September was the first kind of line of code. And what we had to do actually is those productions, you see all the remote controls that they have. It's usually Sony cameras or big brands. And they're all the same, so they all match. And suddenly they wanted to use many of those small specialty cameras. And they were struggling with this. There was no proper solution. And I said, well, someone needs to come with like a panel that does a good job for the operators to be able to use them and get the quality that they want. And well, nobody were doing it. So at some point I said, well, let's do it. And we knew with all those protocols that it was going to be difficult and probably a mess because they're all different. Some are buggy, some are very limited. So that was a challenge. And because it's TV, it's not like you have many chances to make it work. If you fail a couple of times, then you're out. And we knew it would fail. It was impossible to have all those cameras. Actually, we don't own all of them. So we had to find a way that we could still fill the possibility to use these cameras and have something reliable enough. And the way was that as soon as it fails, we need to fix the bug and just push an update. In an industry that actually doesn't like to do update at all, when it works, don't touch it. So we had to do something very different.
So yeah, back in the day, I mean, David and Gillen, who started the company and the whole idea, had no clue about the Elixir and which technology to use back in the day. So the requirements are simple as that. It must be reliable 100%. You don't have the option to fail. So it must be not 99, but preferably 100% up all the time. And then Gillen actually read a book. I think it's called Programming Elixir. It was version 1.3 or so. And he was actually satisfied with the approach, let it fail. Because in the broadcast world, if you have 20, I don't know, 50, 100 cameras, if something goes wrong with one, everything else is supposed to work. And maybe this camera is going to recover and reconnect. So I guess a lot of people here know about the benefits of Beam and its recovery strategies. And so let it fail approach seemed very interesting. And as well, there was a challenge to integrate as many different protocols as possible. So you should not be limited just to the, I don't know, IP or maybe sockets. You should be able to operate on the binary level very well. And back in the day, MQTT still was a standard. And I mean, not still, it was already a standard for the IoT devices, and it was kind of natural to proceed with it. And that's why the MQTT was in place back in the day already. And yeah, as David mentioned, broadcast is a business where you have the only one chance to prove that you're good at. And yeah, that's how the Elixir actually was started in the company. So after reading in the book and being interested in that let it fail approach, and we started verifying, will it really prove that it's a reliable solution?
So we actually didn't really have like a business plan in terms of R&D developments and prototypes, but we had a good partner, MP Visual TV in France. They needed the solution already. So, and they had Ninja Warrior, that was early February. So we had just a couple of months to get something working. And so I started to buy just a development board for a microcontroller, put a few off-the-shelf components, put it in a box I had, print it like at a player. Most of the time was actually coding the thing. And Guilain, I mean, we were just two in the company at that time, worked on the Elixir side. That was running on a kind of Raspberry Pi. We used USB hubs to put like 15 USB dongles to control all those cameras. And we got it running just on time. So the day before, something like this, preparing their on site. And they were able to use it to control 12 cameras, and there were a few more that were experimenting with. And you see the middle bottom picture is actually the production where they were able to use that first remote panel somehow for a full week of Ninja Warrior production.
So yeah, back to Elixir. It was the first point where the Elixir proved itself. So it's really great to work with the binary protocols and reverse engineering. So if you didn't know, it has a zero copy parsing, which means on the embedded devices, it's just a blast, because you don't have too much memory and too much resources available. And it's once you compile it, it's very fast. And here are a few code snippets, examples of Atom Switch, I believe. And you can see how symmetrical it looks, the encoding and decoding, and how pleasure to do that in Elixir. And here is the real example from our code base, how some of the binary commands are being pattern matched to the Elixir. And back to the story.
So that was February, and because it worked, that had to be continued. They had another game show in a fort in the sea called Fort Bourgeois, and they had mini cams in every single room of the fort. So a lot of them, and so we did a few more integrations, like they were using some correctors that we integrated, and so we put the same system in place. We worked a bit more on the core rendering and so on. But so that was working for 3 months because they had like the French shows, and after some other countries, possibly Germany at that time. At the same time, in June, they had the 24 Hours of Le Mans, where they had 12 cars, 3 to 4 cameras per car that they wanted to control. And they didn't really have a good solution. They developed something using PHP, but not for cheating. So they asked us, well, that's another challenge there. And so we had to inject commands on an SQL database. I don't know why they went that way, but we did this so that those commands would go over the wireless to the cars. And the kit was used at the other show. So I developed like a new PCB prototype. So we got that working. We took the week over there to fine-tune, well, there was a lot of things to fix. We did that, and at some point it was all working, and I say it was like Thursday. It's all good, we stop tweaking this, we'll put that neat and clean in the desk, and because I didn't have time to make a casing, so it was still on bubble paper, and put that in the desk, slided the covers around that to protect it, pushed a little bit on that, and then suddenly the old panel went off. I heard like a click sound, and I'd broken like the connector of the flat ribbon cable. That's 50 wires there. And that guy that you see on the picture told me, well, qualifications are sorting, now they turn up the cars, the cameras are coming, can you shade them because they all look bad? And I was looking and say, well, do you have a soldering iron? And then it took like 45 minutes to put like 35 wires to get the whole thing working again. But I focused really on making it good because, and it worked. Somehow when I plugged it, it went back. I didn't try to put it again in the desk, and we use it that way. I mean, I was hoping that for hardware, the let it fail would work, but yeah, it never came back on its own. So, yeah, so the evolution, I mean, we at the same time developed many integrations, color correctors. We also, if you look at there, we had like a router panel with buttons. And so when you pressed to select a camera, the RCP would follow. We had 40 cameras on that RCP, so we needed a way to select them very quickly. So we would select the car and we had access to that camera. Integrating more cameras, we also were developing a small interface so that we would send IP commands and not use USB dongles anymore, so that would convert IP to serial and be on the network.
Yep, and as we already spoke, that it's great to be used with the binary protocols and binary pattern matching. As well, Elixir proved itself as a very good with the concurrent models, and in our case, especially working with TCP and IP abstractions, which you can actually hold in a GenServer and then dump the incoming messages into the Elixir GenServer message. And for the stateful connections, we use it all over the place. And this is a great recovery mechanism, and we have all the logic based on the GenServers. I think the amount of GenServers in our code, it's like 90%. And as well, in terms of the actor model, it's proved as well that it's great in terms of let it fail approach, because each process has its own heap, its own memory, and they're isolated. And one thing fails, everything else keep working. And for us, that was great. And going further, there was one bug with the supervision trees. And essentially, if one of your processes dies too quick and it tries to recover it too quick, then it will be constantly dead, like at some point. And it was, I think, a default strategy back in the day, like long time ago. And now in our GenServers, especially, that's the crucial one. This is the supervision for our MQTT. And we usually have the manual control of all the timings and backoffs and the retries, just to be 100% sure that it behaves in the way we expect. And yeah, after a couple of hiccups, after learning, I guess, Elixir proved as well that it's great for the recovery strategies. So if something goes wrong, might be some connection delayed, or maybe some, I don't know, network issue.
No, even like we don't have all those cameras. Some people made some different settings in the menu somewhere, and then the whole thing collapsed, and we don't know because we never tried that ourselves.
So yeah, you never know what to expect from the external world and what comes to your program, and Elixir is actually great for recovery as well.
Yeah, so September 2017, so 1 year after the first developments, we had the first trade show, and we had like casing, no marking, so that was just stickers on it. And I changed the LCD, and for a bigger one, I didn't have time to change the code, so it was still like not scaled properly. The colors were wrong, but it's kind of working, except that when we set up everything there, I had a bug, and during the demo it would fail. At some point it would crash, and I had to per cycle the thing, so it was not like looking good at the show. And so I was trying to debug this up to the point where that was the first morning of the show, and I was still trying to find a bug. I couldn't, and the show started. I was still there. 1 hour into the show, nobody there, all fine. I was still looking for the thing. And then people came, and so I had like, well, I have no choice. I have to give up. And the last idea was actually to say, well, I added a watchdog. Watchdog is in the main loop. You reset the timer, and if you don't reset it at some point for whatever reason, it reboots the microcontroller. And then I had a button I didn't use, and on that button I put like an infinite loop. So as soon as I hit the button, it would just reboot the RCP. And then I had diagrams just behind me. So every time I saw the RCP crashing, I pressed the button, I went to the diagrams to try explaining things, so everyone was looking at the diagrams. I knew 15 seconds after it would have been rebooted, and back to think, nobody saw anything. And I think it's kind of the closest to the let it fail philosophy of Elixir in the hardware world. And it worked so well that actually I didn't even try to fix the bug. We went like for the 5 days of show like this. Yeah, so we made the show. And and after that, I was like 3 months in China trying to get the first production out. We sold the first kit, and the production was not out, so we had to like 3D print some casing and deliver some prototypes. And well, I could get the production out in March, and the products that you see on the right is somehow what we had. So a panel, a small interface for IP to serial conversion, and there was a computer there that we don't talk much, but at the time, the Elixir code was running on an x86 computer running Debian, and that's the way we designed it at the beginning. And in April, that was our first show in the US. We had developed again more things in terms of the Elixir side and the control of everything. I don't know why we ended up putting so much on the show there. It was like a nightmare. It took a day to try to set up part of that, a full night actually to debug with my colleague that was in Belgium. So I spent overnight to fix all the things that were not working. There were a few working, but most were not working. And but we kind of got everything on track. And the second day was long as well to just finish the setup. And we got our first customers in the US, and that was Monday Night Football, ESPN. So that's one of the biggest shows on the NFL, maybe the biggest. End of 2018. So we had the products, we had done those shows, and we found that there were problems with ESD. All the Ethernet chip would fail, so we returned everything, we understood the problem, we patched all the devices, we sent them back. It's not that we had a lot anyway. But we had to do this, and by the end of the year, we had fixed the production, all the 50 pieces of each product that we had. So we were able to deliver some kits. People were talking about us, and we also found a better factory for the next production. So that's the status that we had at that time. 2019, actually, we won some prizes, some recognition for the product. No, I mean, we did a lot of developments, but obviously the product was not mature at all. It was for early adopters in a very niche market. So it's not like you can build a company based on this. And we actually tried to build a company based on that. The people thing was kind of the hardest for engineer like us. And so we went one more people, one less, and so on. It's like people who are coming to help us and moved away. In the end, we ended up just Gillen and I and 5 more people that were different, focusing back on the product, forgetting about sales, and saying, well, continue to develop the product. So that was the strategy at that time. And so we continued, and we worked on our first video processor, so the VP4 that you have seen this before. In that kind of new factory that we still work with today, has been great. And that device is, again, it's processing video, we'll explain that. We also were working on our next productions, and to make them better, we were to design production testers. And that's like designing a whole new product. It takes time to do this, but that's what we did that year. And as soon as we got the video processor, I don't know how Fox heard about that, and they wanted to test it. They used it on the NFL at the end of the year, and they loved it. And so that was on the first Super Bowl in 2020. Super Bowl was something that I was so, well, it would be so great at some point to be a Super Bowl. And then it came that the product were not ready, and suddenly we were at the Super Bowl. So we've been lucky on that side, but also they love the product. And very quickly, actually, that spread in the US, and Fox, CBS, ESPN were all using, starting to use our products.
Yeah, I mean, David was complaining that for one of the shows in the past, they brought too much and they spent the entire day setting this up. So now we have so much things to bring to the trade shows that this year we spent actually 3 days in a row setting like all the devices up. And yeah, the Elixir in that case actually helps us to organize our code base in a very nice monolith. So we have a lot of different applications which holds different logic, different integrations, different GenServers, different protocols. And based on the device, we can actually create the list of what we need and put only the needed parts on that device and reuse it on any other boxes. So, and Elixir was actually great to organize the umbrella app and create the builds which are necessary.
So back to the VP4, that's based on an FPGA. FPGA, it's a kind of integrated circuit, but you can still program it. It's programmable logic. It's different than a GPU. A GPU, you would have like a full frame in memory. You process the frame, you put back in memory, and you need like a big computer. The FPGA is that big. the module. And it's like you have one pixel in, it's processed, and you have the pixel going out, and it's like a stream. So one pixel in, the next one goes. And in the end, the video goes through, delayed by just a few pixels, a few lines. But that's 3 gigabit per second, for example, for an HD picture. So that's what we call 3G SDI, serial interface, digital interface probably. 4K would be, that one doesn't support 4K, but that would be 12 gigabit per second. And the broadcast industry is moving to IP. 4K doesn't even fit on a 10 gig port. So they need 25, 100 gig ports, 400 gig ports. So it's like very high level in terms of the requirements and the price and everything. But yeah, the FPGA is actually very well suited to handle processing. That means that we don't process anything in the image using CPUs. That's the hardware logic that does it. But we need CPUs to actually control all the parameters of the processing pipeline.
Yeah, so as you can see, the slightest code might be not a silver bullet, because you don't do the heavy math computations in Elixir, and if you have options to do them in C, you usually do them in C. And that was the exact approach which we used. So we take the benefits of Elixir, like supervisor tree, and let it fail approach, combine it with the C daemon, which is actually doing all the heavy computation, and then provides the end 3D LUT file, which we put on the FPGA memory. And then we get the image transformation with a low latency, almost zero. And yeah, so some people were asking, like, why port versus NIF? And some of you might know the NIF will be a bit faster solution. But in our case, let it fail and keep system up actually more important rather than to have maybe, to be 1 second faster. And that's why we chose to go with the ports. And if you have the error in the NIF, it's actually going to crash the entire VM. And in the port, since it's, let's say, isolated process, so we come back to the greatest benefit of Beam and Elixir, so let it fail, so it's going to recover, and we proceed. And the rest of the system going to work.
So the next step for us was actually to launch a new production, and we didn't like the idea that we had the computer on the side. We had to sell 2 products running the Elixir, and one of the person that we had at that time in the company had experience in Yocto. So we said, well, let's take an embedded board, put that inside the RCP, then we'll have the Elixir code and the panel together. That makes more sense, and actually that's the RCP that we have today. It was a great idea. And so we bundled a Linux board and the panel together, and that's the first production that we get of the current product. And so that was an all-winner H3 processor from 2014, I think. Small one, but it's still, I mean, that's still okay. And so we had a new production with this, and the next request we had was to control cameras on motorbikes for marathon cycling race. And well, we had to put like the RCP on a motorbike. The thing that we had now, we had that small embedded board. So we use this. So that's the black box that you see there. And we use our like serial IP to serial interface bundled together. And we were able to control a camera on the motorbike. And then we needed to be able to control from the broadcast trucks, the production center. Everything was an IP for us. We didn't have like the knowledge of going wireless and those kind of technologies. And we didn't want to go through a plane or something to control that. So we simply used a USB cellular modem, go over the internet, and we just had like a small service in the cloud to relay data, and we were able to send the commands from the RCP through the relay to the device that was on the motorbike. And so that actually worked. We shipped like a whole kit of this kind of bundle to PGA. They were doing golf production at the same time. And so we designed a proper product. What you see on the right is actually that embedded thing, Linux board with or schematic of the 2 serial ports. So that was the Rio remote I/O, and that was used the first time on Tour de Suisse in Switzerland cycling race. They had 4 on the motorbikes, 1 in the helicopter, 1 on like a handheld camera, and so you had to relay that in the cloud. That's small server we developed, and they had a lot of RCPs in their truck. So that's how they were controlling all this. And you see inside the motorbike, it's not actually the Rio, the final product. It's still like the prototype with the 2 box.
So yeah, a couple of things. As I said at the beginning, we will explain why certain decisions were done. So for the MQTT, we have a small custom layer on top. So for example, when you subscribe to some specific topic, you get all the latest values which we persist in the database. And now I know the history. And apparently some of the cameras or some of the lenses, if they lose the connection, they try to reset the value back to like whatever default they have. And once they restore the connection, so you have the inconsistent state. So that's why in our MQTT, we actually persist the latest values of the camera. And you can see we follow like some patterns, which is our contract interface in a way, how we communicate between the camera and our device. So each topic has the device ID and then the command or I don't know, or status. And as well, when it comes to the relay, we don't use the MQTT bridging, as I said. We have, once the MQTT publishes the message, that message goes to the via session importer. So essentially, this RCP can import the RIO and send the commands to the RIO via relay, and then the RIO going to spawn its own MQTT message. And it's as well done in a way that if you have one cluster of MQTTs, you might end up having loops. So that's not the part of Elixir, and it's still open to have bugs. I mean, not from the MQTT itself, but from us, from developers. And we would like to avoid having those issues, and that's why we have one way of sending the commands. But at the same time, one RCP can be importer and exporter, and you can do the bidirectional communication. But in that case scenario, we send the action commands one way. So that's how we ensure that there is no loops in the system or any other issues.
Yeah, so the changes you make come from the remote itself to the camera, and the status from the camera, whatever value changes, go back to all the device.
Yeah.
So they all have like the same status in the end, it's all synchronized, but the action only go one way. Because if the action were sent to everyone, then is it like the same, a new one? Should we apply it 2 times and so on? So that's the problems we were facing. And so the next step actually was REMI. It was actually, there was a request from broadcast to control productions remotely from like control centers. If you look at IMG Studios in London, they were now producing like lower leagues of football that were never produced before. And that can be 50, 60 games a day. Most of these are just 1 or 2 cameras. They had a bunch with 4 cameras. And so you don't send teams on site, you just have like the camera operators, everything's done in the center. So we needed a way to control that remotely, and we had done the RIO, and so we did exactly the same. Whether it's a RIO or an RCP on the stadium, doesn't matter. If you have someone that can actually benefit having an RCP, it's the same code anyway for us. So they can use the panel. If they don't use the panel, they can use a RIO, because that's the same thing. And that would control the camera on site, and we would use either a relay, or they have a VPN, or they have like a private fiber. And so we use the same kind of link to the RIO to control from the RCPs in the studio all the cameras that are in the stadiums. And that worked actually really great in that situation. And in 2022, France Télévisions, well, also the 2020, that was COVID. So there was a lot of push from the industry to say, well, now we cannot get our people on site, so we need to control that remotely. And that really boosted the REMI request, I mean, the productions remote. And so in 2022, France Télévisions, they were used to that already. But that time, there was the Olympics in Beijing, the studio there, and they wanted to control it from Paris. And so they put their VPN in place, and actually it didn't work, and asked us, do we have a solution for that? And the reason it doesn't work is that those Panasonic PTZ that they were trying to use, the protocols have not been designed to go over a latency network. So when you control that locally, it's all working, but when it was from a distance, there was like 100 to 300, like typically 200 milliseconds latency. And if you want to change, let's say when I change the iris of a camera, I'm sending like 20 to 50 values per second, ideally 1 per frame, so you have like a smooth response. And so if you want to change 1 value on this Panasonic protocol, you need to open a TCP connection, you receive the ACK, you need to ask a key, you get the key, you need to send a value, you get the ACK back, you need to close the connection, and you get the ACK. And then you need to start all over again. I don't know why, but that's the way those cameras work, which means that it takes like 2 seconds to send one value over the latency network. So that kind of doesn't work, and their panel was just timing out and not even showing the connection. Ours would connect, but that was kind of unusable. So we ended up doing exactly what we did before. We have an RCP on each side. We send like 20 comments. They're all delayed by 200 milliseconds, but they're applied instantly because it's on a local network where there is no latency. And the problem was solved. So we had pretty much nothing to do at that stage. And yeah, so it's we were lucky, I would say, on a few phases of this evolution. Yeah. Back to the VP4 as well, I didn't say, but the FPGA, most of them don't have a CPU inside. It's all programmable logic. But we chose one that have a small CPU, ARM cores. It's kind of a hybrid technology, and the reason that we had some kind of small Elixir code to run on that. Controlling that from the RCP is great because actually that's what people need and want, rather than using a web page or some buttons on like a front panel of a device. But still, now they wanted to have like the same thing as the other ones, like a standalone unit where they could still control it from a web page. And yeah, we had absolutely no experience in there.
So yeah, that was actually one of my first projects. So when I joined the CyanView, David was saying, yeah, we have this GUI which is written in LiveView. It's enormously slow for one simple reason. It runs on the two cores IREM, 32 bits. It has 600 megahertz, if throttling a bit less. And then they wanted to have, I don't know, I think it was like more than 50 parameters plus 32 vectors, which you need to render as fast as possible. So, and of course, the first iteration of LiveView didn't work, and a lot of developers in the company were saying, no, LiveView on the embedded devices is going to be slow. On the other hand, for me, I don't need to do an API. I can just put it on a device, connect to the port, and it's there, right? So you avoid a lot of other things, and to develop those, it can be pretty fast. So I took it as a challenge. I completely rewrote it. I made it from scratch. And back in the day, they didn't use Acto, and we don't need Acto because actually for those interfaces, we don't use any SQLite or Postgre or MySQL. I mean, we still have MySQL, but for other historical reasons, and the PHP with the Lyman arrays. But anyway, using Acto embedded schema, doing the batching of events, like the rendering events, and we ended up having quite responsive GUI. I mean, maybe we even can show it.
Yeah, that's the one running on the VP4. So we have those sliders, and for example, if I change on the RCP, you see it changing there. If I change from here, of course, it's going to change on the RCP. And the multi-matrix that we showed earlier, I have it here. I can change the hue and saturation of a color. So see, I'm changing the saturation. Hue looks a bit slower, but I can change like the saturation of all vectors, and you see that changing on there. So it receives if the status are sent on MQTT. LiveView is also connecting to the same, receiving the status and that, and I can actually change that from the interface itself. So I can move the dots and put that in all directions. So that's one of, let's say, the experiments. We said if we have that interface on the VP4 and it works, that's the slowest CPU we'll ever have. We are not interested to go lower, which means that we just can only get better in the future.
Yeah, and the thing is, VP4, I think, is already discontinued. And I was working mostly remotely, so I had to connect to the VP4 in the office, to my laptop, from my laptop, whatever, through the REMI. And for me, it still was a bit slow. And I thought, like, okay, so maybe other developers gonna say, no, it's terrible. But yeah, actually, yesterday I first time saw it locally, and it's quite all right. Yeah, now we're going back to cinematic market.
Yeah, cinematic is it's like another big step in the company. We mainly were in the specialty market, so there was like a picture in Le Mans where you had all those Sony RCPs, and they had one per camera, and then suddenly you could have like 30 or I think the most we had like 250 cameras, and we had to use 2 RCPs there. But everything, all the specialty are on one. And then they started to use this with cine-style cameras for fashion shows. And the main reason is that Sony came with an FX9 camera, which was a cine-style camera, affordable, very good quality. So it was a good camera to use for multicam live. It was not able to control lenses. It's only like photographic lens, not the lens you need for cinema or broadcast. So we used the Rio. The Rio would control the lens, would control the camera, and that's what we have, I mean, somehow here. But I did the lens control, and so you see all those blue boxes on all the cameras you see there. They actually have a Rio that also can do the wireless data in various ways. And so that's actually the first time that suddenly there were no main production RCPs. It was just ours, because all the cameras were cine-style cameras. So we had suddenly a position where either they could use one RCP for everything, or they wanted to have one per camera, because that's the way some people worked. And so it started to do like from one fashion shows to nearly all the fashion shows nowadays in Paris and going a bit more worldwide. There was one thing that we didn't have at that time is the iris joystick. And iris joystick, it means that you're doing the iris when you move it, and when you turn it, you are adjusting the black level, and when you push it, you're calling that camera. So with two hands, you are able to somehow do 4 cameras at the same time. And we didn't need that before because it was mainly one RCP and you switch between cameras with buttons. So it was a different way. We knew we needed it at some point. We worked on it, but it was not ready. And well, then we were forced to finish it. And mechanically, I mean, there was like a lot of parts. So it was a bit of a challenge, and also to make it right, because the operators are going to put their hands and say, I like it or I don't. And if they don't, then they're not going to use it. So it took, well, we took the time to make it right, and we were lucky again, they liked it. So that's it, they accepted our product for like all new applications. Churches in the US use this with, again, cine-style cameras, a lot of concerts from classical music to Coachella this year. We also took a lot of time, maybe 2 years, to just improve the maturity of the product. So not trying to add a lot of things like we were doing in the past, but really say, well, now we have like serious people using our product and we need to raise the bar. And so we redesigned all the interfaces that we had on the microcontroller to add all the features, but that needed, we had, I don't know, 150 cameras implemented there. We had to go through all those cameras to add the new features and so on. So it took a while to go to the next level. But really, that cinematic, that's something that they put in place just to record. It's not even live. It was like a record of a concert. That's the first like broadcast cinematic truck in the US. And we didn't even know that they would put our logo on the truck itself. So that was a surprise in 2023 or 4. And last year at Coachella, they started to use our system for the 2 main stage. And so, yeah, it was really amazing to shift from the sport industry to some more artistic things. And we realized that more and more they were using that in a different way than broadcast. Broadcast, you make all the camera looks good. And let's say if you have concerts like Coachella, every single show will somehow look as good as the other one, all the same. And these guys are doing it differently. Every single concert is actually having its own look. One can be black and white, not really black and white, but maybe more reddish, warmer colors, or they have like typical look with more contrast, less contrast. I don't know what they do, but it's really like art. And so if you look at what they have, on the left they have a kind of dashboard where they have all the web page of the camera to monitor everything that's going on the camera. On the right they have some tools they can tweak. We call that 3D LUTs. They put a look, they can tweak the curves, a bit like the Multimatrix, but going in all kind of weird directions that you absolutely don't want to touch in broadcast. And so that's the way that they, yeah, as I say, it's more like movies. They put a look on there. And that's something that we don't have on the RCP. And we realized that actually people like our RCP because it's actually rigid. It's more like a proper broadcast tool. If we were going to put all this, then it would not be intuitive anymore. It would not be consistent. And so we didn't want to, we felt the limitation of that. We had spent so much time to make it that way that we didn't want really to break it. And so we would not have the flexibility of other tools. But then we realized, okay, well, we need a software companion app that runs on the side. Maybe it could be like a big screen, it could be a computer, it could be a laptop, a phone, and I can have all of them for different applications around me. And then I would have like a different level of interfacing. So I could keep the RCP to control the camera, whatever is shading to align them together, but have some other tools for the creative side. And that was the beginning of saying, well, we need software now in the company. Yeah, that's the demo.
Maybe just the quick demo. So as you can see here on the screen, what essentially they were using, so it's a Google Chrome with some plugin where you can put multiple web pages on one screen, and that's how you get the current camera values. And obviously, when David told me that they're doing this, so LiveView on the device, batching events, optimizing some assigns and etc. And now you can see live all the values of the camera. So for example, if you change anything.
So I'm changing from the RCP or from the panel. You see that it's actually changing to another camera. And I can see the value. So if I change, well, that one is gain. If I change the gain, it's changing. If I go to the other one, changing iris, we see it changing. I can look at the core temperature. And
so you see the time codes as well. And
if I record on one camera, you will see that the status go there. Record is one of the most important features they want to see, because if it stops recording, they need to put it back in record.
Yeah, and obviously, if they would like to see some other values, they obviously can create a template and bring all the possible values which they wanted to see. So for example, we have the gains, color, black level, gamma. Let's say that we call it code beam. Sorry, it's not my keyboard. And then if you apply this template, you will see only black or gamma values or RGB. And obviously, what you can do as well, it's a virtual RCP on a web page. So you have all the screens which David was showing before just as a web interface. You're able to control all the same parameters of the camera from the web page. So essentially now some people can put iPad next to the RCP and do something there, or just observe all the information from the camera. Obviously, it's the latest version of Phoenix. You have Daisy UI themes and everything. I don't know, maybe they're gonna play with this, maybe not, but I added. And yeah, so it gives enormous flexibility. And as well, if you need to do something specific only for one camera, I don't know, like we were discussing with the Fuji, they have some special filter which supports only by them, then it doesn't make sense to bring it to the physical device, and you can easily extend it on the software part. So it gives like a bit more flexibility. You can follow, and if I change, it's gonna follow everything what's happening on the device. And yeah, I guess we're a bit running out of time.
Yep, so let's wrap up. The question, did it work in the end? Yes, with Elixir we got something reliable. We were able to develop a product that actually the industry really lacks. I mean, the most important is that we have a recognition from the market from those operators that really need our products today, and that's the best we could do. And I mean, really Elixir made it reliable. So that's, you have the details, but we're very happy with that. Also, one thing that I say is we don't have in mind any other way that could have been better nowadays. We didn't look for, but it's not like something obvious came and say, well, we should have been doing that way. So we were very happy with the choice of Elixir in the first place. LiveView also seems to be a right choice for us. At least we continue with that. So it's all good. Numbers. We started with 2, 3, and then we did a lot with 4 or 5 people. We're 10 to 12 now. And if you look at all the things that you need to do to deliver hardware, there's a lot, and so every people count in a team. And that's really how we made it. Maybe we should be like 50. Some people think actually that we're 50 people. Don't think that we have a market large enough necessary for that. But we're on track to go probably 20. 20, but that's still a challenge for us. It's not like what we do the best. There is one thing that I want to do is special thanks to Guilain, that's actually first suggested to use Elixir, but also wrote nearly everything in the code. It's his first Elixir project. is quite a good one, and 200 cameras, integrations, a lot of things. Live warfare, he would be with us today, but it's actually difficult for him to travel. But he really deserves this recognition that we have today. So I think it's the one, and even the company. Just thank you for him. So what are we going to do next? Well, we have plans now for the 5-10 years. We experimented a bit. It was like a trouble period where we did a lot of experiments, and now we know what we want to do. There will be some new hardware. We didn't know how the software was going to go, but now that we started with LiveView, it seems to be clear, and we'll definitely continue with LiveView.
Yeah, obviously, big shout out to our small team. I think, smaller the team, more it matters. And we started with the VP4 experiment, which has actually made us believe that LiveView will work further, because it's a really old and small processor, and even the latest version works fine. And we're going to continue adding more and more stuff, and now we're working on the LiveGrade and completely reworking our configuration page, and we will have much more, and even native desktop app, which is wrapped in a single binary, so that we will be able to utilize the computer's CPU to do certain computation on the field. So yeah, that's.
I think in probably a couple of years we'll give you an update on this. Thank you very much for your time.
I think we have time for 1 or 2 questions. What's the deal here? I repeat what they say, right?
The kit will stay here if you want to come see it during the break. We'll break down at that time.
Yeah, shout out, and I will repeat what you said. Yeah, the question is, what do you use for time synchronization? Yeah, I have to repeat it for the...
No, so time synchronization. Actually, PTP is going to be used by the IP on broadcast. We don't synchronize anything on the control side, so all the device, the Elixir side doesn't have any kind of time synchronization. The VP4 does have, it's what we call GenLock. It's again like an old analog frame video signal or an HD version of that, and we have a frame seek inside, so we can lock actually the output of that. All the broadcast industry is actually locked, so all the frames that the camera capture are there, except the specialty cameras, because, well, they usually don't have like a GenLock input and so on. Specialty, the delay is not like that critical for the lip sync and so on. So yeah, those are the cameras that is not that important. Yeah.
Another question? No? Thank you very much.
Thank you.